So yesterday, welcome Lokesh. By yesterday, we had this Kubernetes introduction. We were seeing like why we need Kubernetes instead of we can instead of using these Docker commands, and what are the components and the architecture of Kubernetes, and in Kubernetes how they installed in the cloud platform. Those things we actually explored yesterday, and then we were seeing the setup local set in locally. If you have to run Kubernetes, what are the tools that you need? Those we have tried to set up yesterday, and then we have run some like kubectl commands, some basic commands we started to run yesterday. Today we are going to start with some of the imperative commands. So yesterday when we were doing this pod deployments, like if you type kubectl get pods, what you are seeing yesterday, like some of the pods are been running in the default namespace. So how we are run, we have applied this kubectl apply -f and then the file name like pod.yaml or something. If I apply this one, you will be start seeing the container, it starts to run. If I do kubectl get run now, you will be seeing a pod has been started to run. Like most of the Kubernetes resources, either you can create by using this declarative format. Declarative format in sense, you specify a YAML file and then you do this kubectl apply, or you can go with running the kubectl manual commands. So today we're going to start with that. Like there is something like command like kubectl run. I giving my application like nginx, and then giving name as like hyphen name nginx. So what's the meaning of this one? This kubectl run nginx instance. Um, the first run points to the name. Sorry, wait. The first run denotes to the pod name. The second, you have to mention the image, hyphen image, and you have to mention some image. I can just mention the nginx itself, and then I put some tag as letters or something. So if you run this one, now you see one more pod is started to run. Previously I started to run some pod which is called Phoenix. We know it is also running with nginx. Now one more pod started to run by using these imperative commands. So like for all the resource, we have the imperative command as well as the declarative commands. So we will be start seeing one by one in the next coming class. For now you just remember this thing. So for now, let me what I do is like, let me delete this Phoenix pod kubectl delete pod, and then the pod name is like Phoenix, uh, and then you delete it. Now the pod is deleted. We know for the nginx pod to run, I have used the imperative command, but you have to take a YAML file out of that. It's also possible. What you do, you do this like kubectl um, kubectl get pods and the pod get pod and give the pod name as nginx. Why I'm doing this one? If I do kubectl get pods, you will know what are the pods running. There may be like a multiple list of pods will be there, like three or four, like how many there can be a number of pods is, right? Currently, if one pod is there, then you specify what pod configuration that you need. You specify the pod name as nginx and give -o YAML. This will output um, the file in YAML format. Okay, now and then what you do, you give this greater than symbol. So in most, it's a Linux command. What's the meaning of this greater than symbol means? So whatever the output this gives, this kubectl get pod nginx -o YAML. If you type this one, you see you it is giving an file in a YAML format. That's the -o means output. -o output in YAML format, then you see the similar kind of pod configuration file here. And then you give greater than symbol and you give some pod name here, like I give like nginx.yaml. If you give, and then you see one more nginx yaml that came, where you actually store this this file, this YAML file. So you can create you can run a pod by using these imperative commands, and then you took output the YAML file, and then you can share the YAML file, and if you want to, you edit it and you do reapply. So here I want to do, what I want to do is like, mm, for the same pod, I feel like I want to modify the image. So I want to modify the image, right? Now the image is latest. When I was running this kubectl run command, I was giving the images nginx latest. Now I want to modify this image. I will modify into like something 1.14 or something, and I save it. And then what I do, I give kubectl apply -f, and then I give the nginx.yaml file. Wait. Hmm. It's saying it's just giving a warning, but if you go to the pods now, kubectl get pods. Now you see, like at 12 seconds ago, it's got restarted. If you type kubectl get pod -o yaml, it will give an output format. And if you check this one, you scroll up. Now see, the image is 1. It's running with image 1.14. I hope you got this thing. Uh, Let me move to the next topic. So we already seen what is this namespace. To isolate any particular environment from the cluster, we use the namespace. Yesterday we have seen like how to create the namespace. We use kubectl create ns means namespace, and I created like dev or something. I think it's already exists. Let me create like qa, and then if you create and if you give get if you look kubectl uh, get ns, it will give the number of namespace here. So this dev namespace is fine, this q namespace is fine. So this two namespaces I created manually. Now what this default namespace, we know whatever resource I create, if I don't specify while resource creation, if I don't specify any namespace, those resources will go to namespace. What are the other namespaces? You see cube system, cube public, cube node release. So these are like in the cube node release, you will have some pods or some details about your node instance. Yesterday we were seeing like master and worker node, right? So it will have some metadata is like some information about the node. So that's what that will be mostly contained in this kube node release. In kube public, it's as a name suggests, it's some of the publicly available information about your Kubernetes cluster that everybody that your team want to be aware. Those things will be available in the kube public, and the main namespace will be kube system. If you do like, if I do kubectl uh, get pods -a means all the namespace. I'm just taking the running pods throughout the all the namespace. That's why I given -a. Now you see, apart from the in the default namespace, I have an nginx container. I know I started to run. Apart from this, you see multiple pods are running, right? These are what is it, like kube proxy is there, APIs server is there, uh, scheduler is there, control manager is there. You can correlate this name, right? These are the components of the of the master nodes. So those are actually also running as a pod. So in mostly the system oriented like some pod configuration, or you like suppose tomorrow you install some extensions, or do some add-ons additions in the Kubernetes. Mostly it will come to the kube system namespace. This is most of these default namespace for the system application. Like Linux, we were seeing some libraries will go to this varlib folders, right? We called, and then in some files will go to etc folder, because we told it's a configuration file. Like any add-ons you add or any information about Kubernetes will be available in the kube system namespace. Uh, Let me move to uh, um, there is one more thing is like um, uh, so we have actually created a namespace called dev. Okay, now I want to run my nginx container in the dev or QA environment. So I already know. my pod is running in the default namespace, right? What I do now is like I have this nginx YAML file. Instead of I go to, you see this YAML file which I took from the container. It will have like a lot of information, but you no need to consider those things. You always stick to the information whatever we give. We have given like API version, we have given you just see these things kind, and then in metadata what we have given some name, and the containers whatever section we know image, we know name section, and some container port we have given. You just keep remember those things. Apart from other configurations, you ignore for now. You don't need to consider those things. um, Now what I am trying to do is like, mm, here if you see in the metadata section there is some section called namespace. Like, but I while I creating this pod, I didn't give the namespace. But what I told, if you don't specify any namespace, everything will goes to the default namespace. What I'm going to do is like, I'm going to delete my pod which is running in the default namespace, and then kubectl delete pod, and then what are you going to say nginx, right? Oh, sorry. If you do kubectl uh, get pods now, they see the pod will not be running here. What I want to do is like, I want to change the namespace from the default to dev. For that I deleted the pod now, and then I have this YAML file with me. I updated the namespace into dev because I know I created a namespace called dev, and then I will do kubectl apply nginx.yaml. And then I write kubectl, and now if you do kubectl get pods, you will not be seeing it in the default namespace because it's running in the dev namespace. Those time you have to give the command as -dev. But now, so each and every time, if we, in order to see the resources in other namespace, you always have to mention the -n. Okay, for kubectl deployment or or like a service or pod, for the, whatever the things are there in other namespace, you always have to mention this tag -n dev. In order to avoid that, there is some command called kubectl config set context is there. So this kubectl config, there are a few config commands that we use. It is like, it changes some configurations related to system. Okay, if I do kubectl config hyphen set context, uh, and then hyphen current, um, and then hyphen namespace is equal to dev. What does it means, I'm setting my Kubernetes, the setting Kubernetes config set current context namespace as dev. That's the meaning of this command. If I type this one, now see context has been modified. Now if you do kubectl get pods without giving -n dev itself, you will be seeing the resource. The reason behind this one, you changed your default namespace from default to dev now. That's the meaning of this one. So now you don't need to specify this thing. Okay, I'm reverting back the changes. I don't want to keep it in dev namespace, so I'm just reverting back to the default namespace here back. Now I type, if you do kubectl get points, you will not be seeing the resource because previously we changed the context to dev one, and that's the reason. If without specifying the -n flag, you are seeing the resource in the dev namespace. Uh, let's move to rest. So we will be exploring these options as well. Like some resource quota is there, network policies are there, or backups there. So the thing is like, we have a namespace here, right? Actually go to Spain. So this is my cluster, right? Consider as my cluster. I'm having a namespace here. Consider you will throughout the cluster you have like 5 worker nodes. Okay, 5 worker nodes you have, and you have with like some four, each and every machine have like 4 CPU core, and 4 CPU core and 8 GB of RAM. Okay, but for particular namespace, in this particular namespace, maybe consider it as like some UAT namespace. Consider it as a UAT namespace. And similar to that, you have like some dev namespace will be there, QA namespace will be there. Uh, but UAT means is before goes to production. Before goes to production, you will be running the pods in higher replica count. In those times, you need an higher resource here. So those time you can use this resource limits. There is some block is there similar to this pod configuration. Similar blocks are there. We reserve the quota. That means no matter what, in my specified namespace where I do this resource quota, you will be having some dedicated resource. Because if you consider, like I told, like five worker nodes, with each worker node with 4 CPU and 8 GB RAM, I am allocating like two of the machines dedicated only to the namespace. So in those case, some resource will be always available to the this UAT namespace. If any of the other namespace trying to get this resource, it cannot get. That's the reason for this doing this resource quota. So we will be exploring those options. You just keep remember this thing. And network policy is there by default. When in a network, in a cluster, each and every pod from dev to QA, it can talk. They can talk with their some DNS entries. We will see that, like dev to UAT, you can talk from, and then some other free namespaces there you can talk. Each and every namespace can talk to each other. Okay, by default, it's allowed in the cluster. If you want to restrict the network flow, because if you feel my development environment should not talk to my UAT, or some other client environment is in the same cluster, this client actually need not, the client one not need not to be talked to client two. Those times you can use this network policies. You just remember that for a concept oriental, we will be seeing that in our in our future classes. Let's move to the next important topic. Next, we should be seeing the deployments. Okay, we already seen the basic commands of pods like kubectl get pods, describe pods, logs. Uh, it's similar to the this exe pod means like. Mm, we have seen this command already in the Docker. If you do kubectl get pod -n dev means you will be having some application is running, right? In Docker, what in order to go inside the Docker container, what command we did? We did Docker exe, and then -it, and then we have given that container name. I'm just giving it as nginx, and then we have given as like bin bash or something like whatever the shell that's available for the Docker. And similar command is it's available for you in the kubectl as well. Instead of Docker, you put kubectl, and then you have to specify the namespace as well. -n. It's because of the uh, shell issue. Wait a second. Sorry, I forgot to give it as bin bash. Okay, mostly it's bin bash, or you can just give it as. If I would have given it as just a bash, it could have been worked. You see, I specified a slash here. Either you can mention the full path like -bin -bash, or you can just specify the bash. It will work. Now we are inside the container. If you do ls -ltr, you do some operations here, and then you come out. How we come out of the container? We execute the command called exit. So we already seen all these commands in our class. I don't want to go further in it. Let's move on to the next section. Let's move on to the deployments and replica sets. So what is this deployment and replica set means? So from yesterday, you can see like I started to talk about the word called replica. Like it will run with you can run the application in like 5 to 6 pods. Like why I'm mentioning is that, so we will not be running the application in a single pod. That's the reason I told we have been one of the reason that we move to Kubernetes. So it's obviously our Kubernetes cluster. uh, So it's obviously our Kubernetes cluster, right? So here we are running a pod. Consider this layer as a pod. I'm just marking it clearly. Pod. Inside the pod, what is running? Container. Inside the pod, you have container. This is cluster. Just mark the cluster. Now, what this deployments and replica set is going to do? If you see, uh, this pod is going to get controlled by the replica set. Okay, this pod controls because in most of the production application or any of the dev application itself, it has to be run with high number of pods. Similar to this single pod, there will be one more pod will be there. Like I consider like three pods are done. This total replication, like we have three pods, right? We call it as a replication. That like these multiple instances are there. This is going to get controlled by the replica set first. And then this replica set is further going to get controlled by the one more layer called deployment. Okay, now see what I've started to roll. First, pod is there. This pod, if I need multiple pods to be running, it has to be controlled from replica set. Then this replica set will be controlled by deployment. So let me first go to deployments. Uh, I just type deployment in Kubernetes. The first you will get. Hmm. Go to this kubernetes.io, there which is like Kubernetes documentation thing. You just copy this thing, and I'm going to my application here. I'm creating one more file called deployment.yaml. See the deployment YAML file, and you just paste it. So here you see the same pattern is going to follow for all the resource. First thing that you will be having the API version. So here the API version for deployment is like apt/v1, and then in the kind this will be deployment, and then in the metadata section you have something called nginx deployment. That means the name of this deployment is going to be nginx deployment. Under the label section you have something called app nginx, right? You see similar to that throughout this template you will be seeing the label as app nginx. You see it three times. You have this label section called app.nginx. So we will be seeing that what is it for any resource that you are running in the in the Kubernetes, you will be labeling that. So we label, why we have to label the segments? I'm just tagging it to provide some identification. Okay, that's the reason began this labeling thing. So in the metadata section you will mostly contain these two major sections. One is the name of the deployment, another one will be the label section. Now if you see what extra parameters we have, if we compare the pod.yaml here, see pod.yaml also already have this spec section, right? You see pod.yaml section also have the similar content of this one. You see something is spec is there where replica is equal to 3. This replica is equal to 3 means 3 pod is going to run this time. When I'm going to run this nginx, now 3 pod is going to run. And then you see something called selectors, match labels is equal to app.nginx, and then you see some templates. The entire pod.yaml file, apart from this API version and the kind, whatever the section you see, metadata, spec, container name, image, ports, this entire section is present here. That's why it's called as template. It's in the template instance. It is the template for your pod configuration. This both these configurations are same. So the entire template pod.yaml template has been moved and it been placed as a template in the deployment. And what else parameter you have? Apart from that, you just have replica set and then selector match labels equal to app.nginx. What it means, if you see in your templates, I am labeling my containers whatever containers running in Nginx, I'm labeling the container as app is equal to Nginx. Similarly, you see some selector match labels app.nginx. What it means is like whatever application running with nginx, with this label equal to app is equal to nginx, it is going to get controlled um, by this deployment. For you to show the demo, see, we already have an nginx .yaml file, right? Let me take let me take this pod.yaml. In the pod.yaml, what I will do, I will update this label section. Okay. Hmm. Say in the metadata section, I'm adding in the pod.yaml file, I'm just adding this app.nginx. Now what I do is like add kubectl apply -f pod.yaml file. Now, if you do kubectl get pods now you see you have, oh, I named it as an nginx. So wait. Now I'm actually applying the pod. Now you see, if you do kubectl get pods, you know a pod called nginx is being created and it has the labels app.nginx. In my, if you go back to my nginx, to my deployment, I can see the similar section, right? Metadata, labels, and then container, image, port. This both the sections are same, right? Now I want to run the deployment with three replicas. What I do is like I do kubectl, I save this file, and then I do kubectl apply -f deployment.yaml file. You use the tab, so it will be autocomplete. If I apply that, now see, kubectl apply, after then what it says, deployment apps nginx deployment are created. If you do kubectl get deploy, now you see a deployment has been created and three pods are ready. But what if I type kubectl get pods, you might think there will be there was a previously I ran a pod called in the pod.yaml file, I ran an nginx container and one more application I started to run, um, a deployment I started to run with three replicas. You might be think there will be four pods are going to run, but if you type kubectl get pods, you will be end upping with so it has some naming convention issues. But what will happen is like, by default, this what labels app nginx is there, right? It's already present in the pod.yaml itself, right? It will be also get controlled by the deployment itself. You got my point. So I deployed this pod.ml separately, but if I have the matching labels and matching, because this created with different names, this deployment is also going to be, this pod is also going to be get controlled by the deployment. So that should have been happened here because of some label issues, and the naming configuration of the pod. It is not taking care of this control. That's fine. So now you see three pods are started to run after I give the three replicas, and the selector label is equal to app.nginx. Whatever application that runs with app.nginx, it is going to get controlled, and you have to specify in the pod templates. You have to specify the same table. So sorry, same labels. Mostly whatever the labels you mention here, it should be similar in the select match labels as well, because this tagging and naming labels is very important, because throughout this Kubernetes, by using this label section alone, one pod is to going to talk with another pod, one like deployment is going to get attached to the pods, service is going to route traffic, ingress is going to send traffic, this network policy is going to get controlled throughout this Kubernetes. Mostly these labels are very helpful in controlling the pod placements. So initially you told about some replica sets, but where is a replica set? If I do kubectl I do RS. RS means replica set. If you do RS, see, here replica set has been created for you. If you do kubectl, if you want to know everything, like instead of like you type kubectl parts rs replica set, if you do kubectl get all means you will be seeing all the resource in the current namespace. Mostly it will be giving the outputs for pod deployments and replica set. You ignore this service. Apart from that, you see we have a three what this deployment is done. This deployment triggered and replica set. This replica set triggered this part. Now what I want to do is like show is like if you see kubectl get deploy and then nginx deploy. And what is my deployment name? It's nginx deployment. You type that nginx deployment and then you give -o yaml. I want to see this is my deployment yaml file, but I want to see it as a yaml file now. So what, and then I want to know, I want to tell you like what's the difference between this deployment and the replica site. If you do kubectl get deployments -o yaml, you see in the uh, if you see you have the same kind of things. What in the whatever in the template, it's all the details will be there, like API version kind in the metadata, labels is there, name is there, and the namespace will be default. We know will get go. But in the spec section, if you see, apart from this template things, there is one more section is getting added, something called strategy. So this strategy is the difference between this replica set and the deployment. You see the replica count here and the select match label section here, and you see the strategy here as ruling update. If you do the same thing for replica set, if I take recall, I'm giving the same command now. kubectl get rs, and what is my replica set name? This one, nginx deploy, some additional uh, numbers are there. You just took that, and then I want to see the YAML file. You see both the YAML files looks mostly similar, right? You have something like API version, you have some kind, you have metadata, you have labels, you have some name section here, and then you have same replica select labels, but and then you have the same pod template section. Both the replicas set and deployments look same, but in the deployment we have something called strategy. That is the deployment will contain additional details about the strategies. So what is that rolling update in means, like by default there are two updates are possible in Kubernetes. Let me open the paint. Consider you have an application which is running with the version v1, okay, and it is running with v1. If you tomorrow what you do, you want to create an image tag with v2, you update that image section. In image section tag is there, right? You just update that it from v1 to v2. Now while this deployment occurs, because already v1 is running, if you change that in the deployment section, I have the tags called 1.14.2, right? If I want to change, if I change it to like 1.15, what will happen is like by default it is using rolling update, and it have some values, some called, wait. Mm. Ah, strategies mentioned, and it mentioned as rolling update, and it mentioned max surge and max unavailability. What is this max surge and max unavailability, and what is this 25%? This 25% means so what's my total pod applicable here? It's 3 pod, right? This max surge means addition. Max unavailable means yeah, whatever that you want to delete. So maximum 25 percentage should get added, and maximum that unavailability is 25%. That means in total like 3 pods are running, so for each pod gets like 33%. uh, that's the meaning, right? If 100% of pod is running means all the 3 pods are running. If one, then the one like a contribution of a single pod will be 33%, right? And what I mentioned that max max are just 25%. That means in the rolling update, what will happen? Each and every pod, this pod will goes down. The v1 will goes down, like, and then v2, first the v2 gets updated here. The v2 of pod, replica pod is going to created, and then the first pod is going to go, and then one more pod is going to come up with v2, and then the second pod will go, and then the third pod will come up with v2 version, and the third pod will go. So that's how this rolling update will occurs. You got this thing? I just want you to unmute this thing and want to tell me you understand this thing or not. Lokesh? Okay, that's fine. Let's continue with the class. Um, okay. So that's how the deployment will occurs. If you go to my slides, uh, you will be seeing the same thing whatever I told now. Like you can create the deployments by using the imperative commands as well, and we were just seeing the same thing. Now if I want to do like I want to delete this deployment. If you do kubectl get all or something, uh, now a deployment is done, right? I want to delete the deployment. Like use the same commands, whatever the pod commands I tell you. If you do kubectl describe and then deployment, and then if you give deployment name, it will be just going to describe the details about the deployment. And then if you do kubectl describe get get deployment and then deployment name, and then if you give -o YAML means it will be giving the YAML file output, that you can copy this one and put it in some file to edit some values. And now I want to like delete this one. Mm, like I do like kubectl delete deploy. I do the kubectl. mm, I want to delete the deployment, so I am giving like kubectl delete deployment nginx fn deployment. So instead of using this imperative declarative format, you can use the imperative commands as well. You can use commands like uh, kubectl create deployment fn image is equal to nginx, and then you give some name to the deployment, like, and I give it as nginx, and then that's it. And then you can specify, if you don't give any replicas, it will start running with a single replica. If you give like hyphen replica is equal to 3, then what will happen for deployments, the major requirement should be like you kubectl create deployment, and you give some name to the deployment, and then you pass the image as nginx, and you specify the replica count I wanted as 3. I think it's hyphen replicas. It's replicas. Now if you see kubectl, um, now you see kubectl get pods, you see a deployment engine is created with the replica set is created with the 3 pods are started to run. But what happens, you are like either you can modify the replica count here, or you can do or type some command like kubectl um, scale deployment, and then you give nginx, and what I'm doing is I want to scale it. I want to scale to 5 replicas. So now if you do kubectl scale deployment nginx means, instead of like either you can edit that, you can use kubectl edit deployment nginx and then delete the replica code, or if you want to directly update it, you can use this command called kubectl scale deployment nginx hyphen replicas is equal to 5. If you do that, if you've done that, and then if you do kubectl get all, now see 2 more pods are coming up. Container is creating. The status is not in running state, is container is creating. If you type on kubectl get all again, now you can see the container started to run. So that's the major that's how the replica counter like controlled by the deployments. And you got the difference between replica sets and deployments. Replica sets will additional to the pod.yaml file, you will be having the section called replicas and select match tables. In addition to that, it deployments will contains the rolling update strategy. As I told, two types of strategies possible. One is this rolling update. This is the default behavior for Kubernetes. But if you want to, there is one more strategy called recreate. Recreate in sense, if I have three replica accounts with running with V1 version, if you update the strategy as recreate, what will happen? The entire three pods of v1 will go down. Everything will get deleted first, and then every three pods is going to come up. That's the behavior of recreate. So you just stick to the rolling update itself, because this is what been default used to be in all the organizations. Hmm. Let's move to the next slide. As I said, you see in the replica set, you have the special section, you have the additional of replicas and selector labels, whereas in deployments, you will be having um, you will be having the rolling update section as well. So there are, I told like two strategies is there. These two strategies like recreate and rolling update are by default supported by the Kubernetes itself. Okay, in the strategy section, you can you can just change the type to rolling and recreate. It's both are possible for you in the deployments. If we go to some deployment documentation, uh, hmm, strategy. The strategy type you see spec.strategy specify the strategy used to replace old pods by new pods, and can be recreate a rolling update. Only these two strategies are actually in native supported by the Kubernetes. Apart from this, the organizations are using two more strategies, which is called canary and blue green deployment. So what is this canary and blue green deployment in sense? Um, Consider you have application running here with a single replica count. Okay, uh, like, and you want a one more version that need to be run. Consider it is like my v1 application running. I need to bring up the v2 as well. What this there's something called load balancer will be sitting here. It will be routing traffic to the v1 only. Once you create in parallel, you create a v2 application, and you feel like you test this application v2 application internally, and you feel safe that this v2 application is good and it's everything is running fine. Then from the load balancer, you route the traffic to v2. Okay, you cut the traffic to v1, and then you route the traffic to v2, and then you delete the v1. This is called blue green deployment. The first v1 version you can call as blue, the v2 version you can call as green. So this how the blue green deployment strategy is. Canary deployments in sense like you have multiple pods running with a V1 version here. I consider like three in the V1 version I have three replica accounts. In the parallel to that, I will be creating a V2 version. The traffic from the load balancer will be routed to both the version, but if you see in the total we have four pods, right? So 75% of traffic will be going to your v1, 25% of traffic will goes to your v2. So if any issue occurs, you can identify that, and then you can reduce, and then you can delete v2 or v1. If you feel there is some issue in v2, you delete the v2. If v2 is working fine, you delete the v1 and increase the traffic to v2. That's what the canary deployments. So this actually these deployments are actually not natively supported by the Kubernetes, but we can do some configurations. So this blue, green, and canary can work for us. We have to update the deployments in such a way that we have to handle it manually. Once you get familiarized, you will be you know how to handle this blue, green, and canary deployments. Let's move to the next slide. So whatever I told, It's I actually put it in the strategy, the rolling update, recreate, what is canary, blue green. You can just simply see these images to get understand. Uh, then the deployment YAML file comes, and for now you ignore. You just keep remembering these commands alone for deployments. Let's move to the service now. Uh, I don't want to teach demand sets and get confused here. So obviously we'll see everything if we have some time. First, the whatever we've seen in the Kubernetes now, we have seen the architecture and we were seeing some basic commands, and then we were seeing pods, and we were seeing replica set, and we were seeing deployments and the basic commands, that what you have to execute with kubectl, and how to, what is namespace, what's the need of the namespace, and concept wise whatever we see, like what are the deployment strategies that we have, and components of Kubernetes architecture. Now we will see one more thing called service. Um, the diagram still remains here. So you remember that diagram, what I write. So these deployments are actually used to control the replication of pods. Okay, that's the actual need of deployment. But in network point of view, somehow I have to route the traffic to the deployment, right? Then only I will get the traffic. I will be able to access the application, right? To have this network control, there is some service called service. Something service is available here. This service only goes to this deployment pods and controls the network traffic. See, pod is there. Pod is get controlled by this replica set. Replica set is get controlled by deployment. This is fine. But the traffic from the outer world, because you are sitting somewhere in the world, like you are sitting somewhere in the world, like in Bangalore or something, you access this cluster. This cluster will forward the traffic to service. Service will forward the traffic to the actual pods. So in between, you need something called service here. Let me go to the Kubernetes documentation. I do like I type Kubernetes service KTS manifest. I type, you get a first link. You go inside that. Uh, you just copy that service. Now I go back to my project. It's service.yaml file. See, it has a some service name. I just modify the service name. You see, the same template is getting mashed here. Now you see, API version is v1, kind is service, metadata. I'll be updating it as I'll be updating like Nginx service something. Update as Nginx service, and then some selector is there, right? What is this selector? This selector will be helping Kubernetes to whatever selector you have. So in the deployment.yaml file, what labels we have? We have app.nginx, right? I'm copying that and pasting in the selector. Okay, because by using these labels alone, it will know, this service will know like which pod I have to reach by using this, because in the deployments we know like this pod section have something called app.nginx labels. I have the same thing in the selector label, so this service will get to know to which pod it has to reach, and then I put the port as 80, and then I put the target. This port means you will be get confused now only. So I didn't specify in the deployment environment file, I didn't specify the it's already there in the port 80 is mentioned. So whatever let me go back here. Hmm. This is your like pod, you consider it as a pod. Okay, let me consider it as a pod. It is a pod, and it is running on the port 80. Now service is there, SVC. So here some port has to be mentioned. Okay, I'm mentioning it as a 80 now. So what it means, In the service configuration, in the service manifest, the target port means the pod's port. Whatever pod in deployment, if you see the container port is running on 80, that should be mentioned in the target port. And this port means service should run on port 80. This port is different, and then this target port is different. And I given the selector like app nginx, so it will goes to that nginx port. Now if you do kubectl apply hyphen service.yaml file. Now you see the service is get created. If you type kubectl get all now, you something you see nginx service is started to run and it has a cluster IP called with some 10 dot series and it is running on 80. Okay. Now you got to know, right? If you and it see the type as cluster IP. In the Kubernetes, we have four types of services. For now, you just consider the cluster IP. I don't want to teach everything at a particular day. I believe this is fine for now. I don't want to get loaded too much things in a day itself. Uh, you'll see until this deployment thing you can find. This how the general stack will be looking like. You have pod, you have deployment, on top of that you will be having service. In top of the service you will have one more something called engine ingress. We will be seeing that by tomorrow. uh, I'm stopping the